Imagine this, a missile tears through the sky at 9 times the speed of sound, maneuvering mid-flight like an angry wasp on espresso, and before ground radar even fully realizes it's been launched, it's already halfway to the target. Now imagine an AI-driven defense system, a digital war wizard predicting that missile's trajectory before it's even entered the atmosphere, coordinating interceptors, lasers, and drones with millisecond timing. Welcome to the next chapter of military madness, the Hypersonics versus AI defense arms race. And it's not science fiction, this is happening right now. Hypersonics Unleashed. Hypersonic weapons are the cheetahs of the missile world, only they don't just sprint, they redefine what fast means. Any missile traveling faster than Mach 5 is considered hypersonic. Unlike traditional ballistic missiles, hypersonics don't follow predictable arcs. Instead, they can glide, dip, twist, and roll as they fly, making interception by current defense systems like trying to catch a fly with chopsticks. Blindfolded, Russia has been first out of the gate with serious deployments. The 3M22 Zircon, for instance, is a scramjet-powered cruise missile that can reach Mach 9 and has a range of around 1,000 kilometers. It entered active service in January 2023, and Moscow has been quite proud to show it off. Then there's the Avangard Hypersonic Glide Vehicle, which is capable of flying at a mind-blowing Mach 20 to 27 and is nuclear capable. It's been operational since 2019, which gives Russia quite a lead in this space. Not to be left behind, the United States is scrambling to catch up. The Hypersonic Attack Cruise Missile, while promising, has been delayed to 2027 due to budget issues. Meanwhile, the air-launched rapid response weapon, which was previously shelved, was recently resurrected in the 2026 defense budget. There's also DARPA's Hypersonic Air-Breathing Weapon Concept Project, which is still in the testing phase and shows potential to be both fast and agile. Lockheed Martin is also developing the Mako, a dual-mode missile designed to fit inside the internal bays of F-22 and F-35 stealth fighters. India has entered the chat with the LRASH-M, an indigenous long-range hypersonic missile with a projected speed of Mach 8 to 10 and a range over 1,500 kilometers. Though still in development, its test flights have generated considerable buzz in the defense community. Iran, too, claims to have a Mach 15 missile called Fatah. However, experts are skeptical about its actual capabilities, and Israel recently claimed to have intercepted one with 95% efficiency. On the money side of things, the race is expensive. The US requested around $6.9 billion for hypersonics research and development in fiscal year 2025, a hefty jump from previous years. The Missile Defense Agency also sought $76 million for tracking space sensors that could help detect and follow hypersonic missiles. The US Army's Dark Eagle hypersonic weapons are slated for deployment by 2026, and that program alone reflects America's sense of urgency in this new arms race. AI defense systems. While missiles are getting faster, defense systems are getting smarter thanks to artificial intelligence. AI defense systems use machine learning, real-time data processing, and predictive modeling to detect threats faster than a human ever could. These systems aren't just glorified calculators, they're autonomous decision makers that can process vast sensor inputs and make split-second judgments that could determine life or death. The United States has already started integrating AI across its defense stack. In mid-2025, OpenAI secured a $200 million Department of Defense contract to develop advanced AI tools for logistics, cyber defense, and even battlefield medicine. Project Thunderforge, a Pentagon initiative in collaboration with Scale AI and major tech firms, aims to embed AI into every level of military planning and real-time battlefield decision-making. Across the pond, the UK is investing £100 million in AI-powered drone gunships designed to accompany Apache helicopters. Japan has formed a dedicated AI and drone warfare task force, and Australia recently ran real-world military exercises using AI battlefield assistants like Athena AI and SAF Foresight. The US Air Force Research Lab is partnering with Stream Engine AI to integrate tactical AI into operational planning tools. Israel has leaned heavily into AI during recent military operations. Systems like lavender, and gospel have been used to assist in targeting, although their use has sparked serious ethical debates. Meanwhile, private defense companies such as Anduril have developed a suite of AI-powered systems, including Roadrunner interceptor drones, Barracuda loitering munitions, and autonomous surveillance platforms. What's the benefit? Speed, primarily. AI systems can react in seconds, or milliseconds, far faster than traditional command hierarchies allow. They also reduce cognitive load on human operators, meaning fewer mistakes and faster coordination across units. However, there are concerns. AI systems can be opaque, often described as black boxes, making accountability tricky when things go wrong. And there's always the risk of hacking, misidentification, or in the worst case, rogue autonomous behavior. Clash of Titans, speed versus smarts. This arms race boils down to a classic battle, raw speed versus rapid thinking. Hypersonics are all about overwhelming speed and unpredictability. AI defense systems aim to predict, analyze, and respond faster than a missile can arrive. And it's not a theoretical contest. Real-world scenarios are already testing both sides. When a hypersonic missile is launched, ground-based radars often don't detect it until it's already in the terminal phase. That's where AI-driven sensors and space-based tracking platforms like the Hypersonic and Ballistic Tracking Space Sensor, HBTSS, come in. These sensors use AI algorithms to detect the thermal signature of a missile in its early boost phase and calculate its trajectory before it dips below radar coverage. In a hypothetical encounter, say Iran launches a Fatah hypersonic missile toward an Israeli target, the defense network springs into action. AI-powered radar and optical systems spot the launch within seconds. Algorithms crunch the missile's flight path, predict its maneuvers, and alert multiple layers of defense. Interceptors, drone swarms, and even directed energy weapons. Patriot-type systems engage. AI-guided drones try to confuse or distract the missile, and experimental ground lasers add to the chaos. Will it work? Maybe. Even with all that tech, a Mach 15 missile gives defenders barely a minute or two to act. And then there's the cost. A single hypersonic missile can cost anywhere from $10 million to $18 million depending on its complexity and origin. That's not cheap. However, AI platforms once developed and deployed scale far more affordably. You can't fire a hypersonic missile more than once, but you can deploy an AI decision maker across dozens of battles. Smarter, faster, deadlier. As we speed into the second half of the 2020s, the arms race between hypersonics and AI is only accelerating. Global military spending hit $2.44 trillion in 2023, and with current geopolitical tensions, see China, Taiwan, Ukraine, Iran, defense budgets show no sign of shrinking. Both AI and hypersonic technologies are top funding priorities in nearly every major military power's budget. The technical trend is clear. Hypersonics are becoming smaller, more accurate, and even stealthier. AI systems, meanwhile, are evolving into fully autonomous mission managers, coordinating troops, drones, interceptors, and even satellites in real time. Integration is the name of the game. The side that merges these systems most effectively, fast weapons with smart defense, will hold the strategic edge. But this is also an ethical minefield. Who should authorize AI-driven counterstrikes? How do we ensure accountability in a war room full of algorithms? And can we build safety nets that prevent rogue AIs from triggering unintended conflicts? These are not problems we can leave for future us to solve. They're already knocking on the door. Thanks for watching. If you enjoyed diving into the high-stakes world of Mach speed missiles and machine brain defense systems, smash that like and subscribe. Got thoughts on who wins the arms race? Team Speed or Team Smart? Drop your take in the comments.